Hi ladies and gentlemen, today we're going to be talking about finding the LCM and GCF and using that to help us solve some word problems. So first I want to go through a different technique or a different strategy to find the LCM, least common multiple, and the GCF, greatest common factor. So for our first example, we want to find the LCM and GCF of 24 and 40. So we practice this strategy with factoring. And I want to put both numbers next to each other. I'm going to set up this little symbol that looks like the upside down division sign like we did with factoring. And I want to find the largest number that goes into both 24 and 40. Off the top of my head, I know that 4 goes into both of those numbers, so I'm going to divide both of those by 4. 24 divided by 4 is 6, and 40 divided by 4 is 10. I notice both those numbers are even, so I can divide again by 2. So we're going to add another layer. And 6 divided by 2 is 3, 10 divided by 2 is 5. So to find the GCF is the product of these outside numbers on the left-hand side. So our GCF is 4 times 2, which is 8. Excuse me. Now to find the LCM, we're going to multiply the numbers on the outside here. And it's going to form this L shape. That reminds me that I'm finding the LCM. So my LCM for 24 and 40 would be 4 times 2 times 3 times 5. 4 times 2 is 8, and 3 times 5 is 15. 8 times 15 would be 120. So our least common multiple is 120, and our GCF, greatest common factor, is 8. Let's do another example. Right, so for B, let's just find the LCM of 27 and 36. So again, I'm going to put them next to each other and set up this upside down long division sign. I know that 9 goes into 27 and 36, so I'll put that on the left-hand side there. 27 divided by 9 is 3. 36 divided by 9 is 4. To find the LCM, we're going to multiply the numbers that are on the outside, so that left side and what we're left with on the bottom. Again, what I highlighted looks like a capital L. So our LCM is 9 times 3 times 4. And in my head, I know it's going to be challenging to multiply 27 and 4, so I'm going to do instead 12 and 9. Remember, commutative property tells me I can multiply in any order. The product will be the same. So 9 times 12 is 108. So our least common multiple for 27 and 36 is 108. Let's do one more here. We're going to find the GCF of 96 and 72. Let me write down one next to the other. Our upside down division sign. I know that 8 goes into both of those numbers, so let's divide by 8. 96 divided by 8 is 12. 72 divided by 8 is 9. I can keep going further, so we're going to divide 12 and 9 by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. We're going to stop there. We can't divide any further, and we're going to multiply these two on the left-hand side to give us our GCF. Greatest common factor. So 8 times 3 is 24. So our GCF here is 24. So now that we've looked at the strategy to find the GCF and LCM a little easier, let's take a look at some word problems. Alright, so on the top here, Jen has 60 bottles of water and 36 cans of soda. She wants to create some identical refreshment tables that will operate during the school basketball game. She also doesn't want to have any sodas left over. I should say any soda or water left over. All right, so what is the greatest number of refreshment tables that Jen can stock? So if I'm thinking about this problem, I notice the key word here, greatest number of refreshment tables. So that makes me think I want to split these up into smaller groups. So that means I'm looking for the greatest common factor because factors are always smaller than the original numbers we're given. So I'm going to put one number next to the other, and we're going to divide. So I see that 6 goes into both of them. 60 divided by 6 is 10. 36 divided by 6 is 6. Both of them are even, so that means we can divide both by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So I can't go any further. I'm going to multiply these two together. That gives us our GCF of 12. And that tells us the greatest number of refreshment tables. So 12 is the number of tables that we can do. If we wanted to know how many of each water or soda would go in, I'm going to label this water on the top, so the number directly below would be 5. That means 5 waters would go at each table. And over here, this is our soda, so that means 3 sodas at each table. All right, let's go on to number 2. For a birthday party, Harjat is creating individual servings of snacks. He has 27 bags of chips and 18 bags of pretzels. If he wants each serving to be identical with no food left over, what's the greatest number of servings Harjat can create? So this is a similar kind of question. It's asking the greatest number of servings. I have a limited amount of chips and pretzels that we're going to break into smaller groups. So that implies I want to find the GCF. So I'm going to label things a little bit differently this time. Chips, 27. Pretzels, 18. And again, we're going to divide. I notice 9 goes into both of those. So we have 3 here and 2 underneath the 18. So it's already set up for me. I don't have to divide any further. This 9 tells us the number of servings. And you can see here, this would be the number of chips per serving. So that's 3 chips per serving, or 3 bags of chips. And this 2 represents the number of pretzel bags per serving. And I'll just write pretzels per serving. All right, I have 2 more questions here. Let's take a look at them. Excuse me. Samuel and Abby are shelving books at a public library. Samuel shelves 4 books at a time, whereas Abby shelves 6 books at a time. If they end up shelving the same number of books, what is the smallest number of books each could have shelved? So this problem seems a little bit different. I know that Samuel is continuing to put 4 books on the shelf over and over and over. Abby's continuing to put 6 books on the shelf over and over and over. So they don't have a limited number of books that we know about. They can continue to do this over and over until they have gotten to the same number of books. So this is not a GCF problem, this is an LCM problem, since we're continuing to count by 4s and 6s. So I'm going to set it up here. This would be Samuel, Abby, and both of those numbers are even, so we're going to divide by 2. 4 divided by 2 is 2, 6 divided by 2 is 3. And to find the LCM, we're going to multiply on the left and the bottom. So we would have 2 times 2 times 3. That's 4 times 3, which is 12. So 12 is the smallest number of books that they each would have shelved to shelve the same number of books. And the last question, let's try out here. 2 neon lights are turned on at the same time. One blinks every 48 seconds, and the other blinks every 36 seconds. How many seconds will pass before they blink at the same time again? So we don't have a limited amount of time here. This blinking of the lights is going to go on and on forever, kind of like counting with multiples. So that tells me we're going to be looking for the LCM. Both numbers are divisible by 6 and 12 actually. 48 divided by 6 is 8, and 36 divided by 6 is 6. I'm going to keep going. Both numbers are even, so we'll divide by 2. So we end up with 4 and 3. And again, to find our LCM, we're going to multiply the left numbers with the bottom numbers. So that would be 6 times 2 times 4 times 3. You know, 6 times 2 is 12. 4 times 3 is 12. And 12 times 12 is 144. So 144 seconds will pass before they blink at the same time again. All right, if you have any questions, please log in and meet me at the video chat. Hope you're having a good day. Talk to you later. Bye.